We are Automation Innovation and we chose Challenge 6. This is our overview of the project.
This dashboard presents a clear work center level view of delivery behavior by linking capacity pressure to delivery outcomes, directly addressing the brief's requirements to identify reliable execution, overload, and inconsistent performance. At the top of the page, we summarize the overall system position. On average, work centers are operating at 115% utilization with a total 7,000 hour total shortfall between forecast and actual capacity, and over 200 activities currently flagged as at risk. This indicates that delivery risk is not isolated but systemic. These can be broken down into individual work centers when clicking onto the table. This dashboard breaks everything down by work center, showing average utilization alongside miss rates. This allows us to quickly distinguish between centers operating within capacity and those consistently exceeding it. By hovering over each work center, we can see how float changes across the snapshot period, worsening for certain centers compared to others. The main scatter plot brings these dimensions together. Each point represents a work center activity plotted by utilization and miss rate, with the size of the bubble indicating the number of at-risk hours remaining. This lets us separate behavior types rather than just performances at one point at a time. In the lower utilization, lower miss quadrant, we see reliable execution behaviors where work centers are generally converting capacity into delivery effectively. In contrast, the upper right quadrant highlights work centers which are both highly utilized and consistently failing with elevated levels of missed and at-risk activity. This indicates sustained overload and resourcing constraints rather than isolated planning issues. A third group is displayed volatile behavior, alternating between periods of acceptable performance and significant delay in the middle. This highlights a lack of resilience to workload changes. This overall classification demonstrates how combining capacity trends with delivery outcomes provides a more meaningful understanding of execution behavior than single period performance metrics alone. Overall, the dashboard shows that while high utilization is strongly associated with delivery failure, not all poor outcomes are explained by load alone. This creates a clear framework for the next stage of analysis, which looks at why these behaviors are occurring and what interventions are most appropriate.
This dashboard shows the disparities between delivery units, offering some insight into why some of the work centres from Delivery Unit 5 have the highest miss rate. Business Unit 5 is performing the worst because they have the lowest capacity and the second highest demand, creating pressure points, the highest utilisation, which gives them little flexibility to absorb extra workloads. They also have slightly less committed work compared to other delivery units and more uncertainty in what type of work they have in status not known. This uncertainty makes planning harder, limits confidence in forecast baseline dates, and ultimately increases delivery risk.
The first dashboard on this screen analyses the total number of activities at risk through each snapshot timeframe and the forecast finish date variance against the baseline. The combination of both of these show that schedule habits across all programs are very optimistic initially, resulting in all programs starting on the back foot and trying to catch up as each program progresses. Using filters, you can also see that the schedule is far more erratic for uncommitted work. The second dashboard you can see looks at the schedule float data to analyze activity slippage throughout the snapshot timeframes. There is no general trend across the programs, however each graph is very erratic with lots of peaks and troughs in float. This would suggest poor scheduling habits are consistent throughout with a high level of change.
So from a data science perspective, I tried to build a logistic regression model, but there were vast errors in the data set itself, and it was very skewed. This was the first model I built, which shows a lot of overfitted signs. This was the accuracy and precision, etc. As you can see, it's close to 100%, which shows this. There was also a big underlying issue in the skew in terms of the target variable. This will just innately produce a bad model. The target variable was highly correlated with the first column there, which again is based from the target variable, so some multi-collinearity going on there. The second model I built was slightly better, but again, accuracy scores close to 100%, so there's vast skewness and errors in the underlying data, so a model is quite bad. And there are just a couple of suggestions to, in the future, improve this so a model could be built.
So to sum up, our recommendations are: Work Centre 5 needs additional support. Try to get teams to commit to work as early as possible. More realistic initial schedule baseline so that teams don't start programs on the back foot, and less erratic schedule updates.
We use various data visualization tools in Power BI to find key trends within the data and understand why issues are occurring on our projects. Our main mechanism is the Python model we created, which learns from previous projects, and with more robust data to train it, as we have recommended, we believe it will be useful to predict which activities will be at risk in the future.
For question 2, we created interactive and easy to read dashboards in Power BI. These were made initially with senior leadership in mind, showing a comprehensive view of the programs. However, using the slices can reveal more specific details and trends at a project and team level, which suits the needs of project managers and team managers respectively.
This solution has been made within Power BI and the Microsoft stack, with lots of companies align. If not, these dashboard tools could be easily replicated in other tech stacks, for example, Tableau. All Python code is open source with no unique libraries, so all would be needed as a Python IDE.